Okay, welcome to ACT Prep Day 19. You should have your blue bell ringer sheet handy. So get started on that bell ringer. Again, this is a table for admission prices to an amusement park. So again, it's per person. And pause the video, answer the questions. Again, you've got 2 questions there. And restart the video when you're ready to check your answers. Okay, so let's check our answers. How much is it going to cost Michelle to attend on a Tuesday? She's got 2 adults, 1 student, 1 child, and 1 senior. So that's going to be $48.50. But if they choose to go on a Sunday, which is a weekend anyway, you can see everybody is $7, so it's $35. They would save $13.50. It's almost like getting 2 free. So this might be a real world problem that you figure out because it's much cheaper. Yeah. Okay, today we're doing multiplying and dividing variables and exponents. Starting to get into a little pre-algebra. Again, you've had this already before. This should be a review. You can only multiply and divide variables if the variable is the same, okay? If the variable is not the same, then all you have is a ratio. And one of the reasons for that would be, okay, I'm going to use this. I can't divide, I don't know if you can see this, silver paper clips by mint green ones. They're not the same. They're not. Okay, if you specifically want a silver paper clip, then you want this one. The mint green's not going to do. This is probably an X and this is a Y. You can't just go, oh, well, they're paper clips. Well, one, they're different sizes. So you might need this one for more paper. Maybe you don't want the colored one because maybe you're a boy and you think the color's cheesy. Or maybe you're a girl and you want the color because it's pretty. Yeah, I like the color. So if you were ordering, say from Amazon, and you specifically wanted the mint green ones and they sent you this one, you're going to be mad because that's not what you ordered. So you can't just like, okay, X and Y, they're the same thing just because they're paper clips. No, we've got them separated for a reason, and it could just be as simple as color. So when we divide, variables have to be the same. And we can divide numbers like the number 1 divided by the number 2 because they're the same. They're both numbers. Here we've got, you can see in the example, you can multiply an A times an A, which gives you A squared because A and A are the exact same thing. But you can't multiply an A times a B. They're 2 different things, like the mint green paperclip and the silver. We can also divide variables when they're the same. Like x to the 3rd divided by x is going to give us x squared. But if we have x cubed divided by y, that's as simple as it can go because that'd be like dividing boys divided by girls. You can't divide a boy by a girl. It's impossible. They're not the same unit. So again, now this is where a lot of students really struggle. When you multiply variables, you have to add the exponents, okay? So we have y to the 3rd times y to the 4th. This is going to give us y to the 3 plus 4, which is 7. And the reason is, let me go back. If I drew this out, I'd get a y. It's not giving me. I'm going to get a y times y times y. That's my y to the 3rd times y to the 4th. Y times y times y times y. Are you annoyed with me saying y yet? Because I am. And so then when we count, that's simply y to the 7th. So somebody recognized a pattern, and that's a lot of what math formulas are. Somebody recognized a pattern and said, I don't need to write this out every time. You simply go, oh, 3 plus 4, and it's y to the 7th. Now, one of the things I teach my students to know whether you add or multiply, we'll get to when you multiply the variables a little bit later. Ask yourself, how many times does y occur? twice. There's one y, there's my second y. How many variables do I have? 1, 2. These numbers match. I have y occurring twice, and I have 2 variables with the y. When they match, you add the exponents. When 2 equals 2, you add the exponents. The same thing would happen for division. If you're dividing, you're going to subtract the exponents. Because if I drew this one out, it would be b times b. Try not to say it the whole time. Divided by 3b's. Because remember, a negative exponent is directional. It just means if it's in the numerator, you put it in the denominator. If it's in the denominator, you move it to the numerator. So these cancel. B over b is 1. So again, we're left with b squared. Another pattern. So that just means, like here, you add them. 5 plus negative 3 gives us b squared. They're multiplying here. I said dividing, but this is multiplying. If we are dividing, so we have it with an actual divisor, you're going to subtract it. So here, we've got it written more like that. Since we have it written as a fraction, y to the 5th divided by y squared, you're going to subtract it. Now, if we wanted it where it was multiplication, we could do y to the 5th times y to the negative 2. And then you'd add. But I always think division, 5 minus 2 is going to give me y to the 3rd. And the reason why is what I showed you a minute ago. We'd have 5 y's on the top, 2 y's on the bottom. 2 sets would cancel out. We'd have 3 left. Here, a to the 2 over a to the 6. 2 minus 6 is going to give us negative 4. So technically, this would be equal to 1 over a to the 4th. Because sometimes you're going to get problems that say, make sure your answer is only with positive exponents. So if it's a to the negative 4, you just drop it down to the denominator. That's another lesson, but a little hint there for you. Actually, no, it's not. It's right there. I knew it was coming sometime. Again, if an exponent is positive, if it's a to the negative 4, it's in the numerator, so you drop it to the denominator. If for some reason you had 1 over a to the negative 4, it's in the denominator, so that just would mean you'd move it to the numerator. You just would move it up. Now, what happens when you have a variable with an exponent raised to an exponent? Now, this looks completely different. Okay? So this is x squared y raised to the 2nd power. So we could technically rewrite this as x squared y times x squared y. And if we did the long way, the long math, we would do x squared times x squared, which is going to give us x to the 4th. And then y times y, which is going to give us y squared. Piece of cake. It's a small binomial, or monomial, sorry. It's easy to do. But when you get really, really large numbers, that's going to take a lot longer to do. So it's helpful to know this shortcut, this cheat. So when I look at this, remember technically that y by itself is y to the 1st exponent. So just like I told you before with adding, count how many variables you have. It used to be before count how many times y occurred. Now we're counting how many variables. So we have an x and a y, so that's 2 variables. How many exponents do we have? We have a 2, we have a 1, and we have a 2. So we have 3 exponents, and that's the key. You got to remember that's y to the 1 power. It's got an exponent. These do not equal each other. So instead of adding, we multiply. Okay? We're going to multiply. And this is the biggest mistake students make is when they're supposed to add, they multiply. So that means we take this, and it's kind of like the distributive property. We're going to distribute this exponent through each term. X squared is going to give me x to the 4th, y to the 1st. squared is going to give me y squared. Okay. And so it just gives us a nice shortcut because you'll get ones like these. I have 2 variables, but I have 3 exponents. The numbers don't match. That means I multiply. So like, ooh, think of it like this. Ooh, the numbers don't match. No, no. That's a multiplication sign. 2 does not equal 3. Multiply. So 3 times 4 gives me 12. 3 times 2 gives me 6. Okay, numbers don't match. Multiply. Let's try our ACT example. Here, I want everybody to pause for a minute. Try this one on your own. Think. A lot of people get this one wrong. Yeah, let's check and see who gets it right. Pause. Okay, unpause. Yes, here we go. Let's check and see how many of you got it right. I'm going to do the answer first just to... No, I don't want to do that. How many of you thought it was C or D? Yeah, it's not. It's none of those. Because I guarantee you I know what you did. Most of you went, oh, I have to multiply the exponent. So 3 times 2 is 6. No. It's the #1 mistake students make when they see this. I used to make this mistake. It's 2 cubed. So what is 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. Yeah. So it's got to be A or B. Yeah, probably caught several of you on that, but I bet you'll never forget it again. Now from here, this is where you've got to go. How many variables do I have? I have 2. How many exponents? I have 3. They do not match. So am I adding or am I multiplying? Multiplying. So 3 times 3 is 9. Oh, I can almost say yes, because they're testing to see, are you going to add or are you going to multiply? Now, this one's a great example where you might have skipped over one and forgotten, ooh, is it add or is it multiply? God, I can't remember. I know one's add and I know one's multiplication, but I can't remember. This is a great one because when I look at it and I go, okay, if I add 3 and 3, ooh, I get 6. If I multiply, it's 9. Which one is it? Look at the y's. 3 plus 4 is not 8. But 3 plus 4 is 12. So in this scenario, the problem's telling me I multiply. So that means when variables and exponents equal, I add. Little hint there. Okay, so let's go to our practice problems. You got 6 questions today. Hit the pause, or first set your timer, 6 minutes. Write down how much you have left, or if you went over, that'll tell you you might need some more help on it. Pause it, do your questions, and then unpause when you're ready. And go. Okay, unpause, welcome back. Let's check our answers. So multiplying and dividing variables. First of all, you should know that product means what? Multiply. We're going to multiply. So you just kind of go like this. What is 4 times 3? 12, yes. So it's not this one, it's not this one. Aha, got rid of 2. Now, count your variables. I have 1, 2, 3, 4. Count your exponents. I have 1, 2, understood 1, understood 2. So there's 4. When 4 equals 4, we add. So 3 plus 1 is 4. Eliminates that one. And 2 plus 1 is 3. There's my answer. Now let's evaluate this one. I always separate these just because it makes me see it better. I put the X's in a column together, and then I put the Y's in a column together. Because when you get to Algebra 2, you'll have like X, Y, Z's, A's, B's, you'll have a lot. So I know I got 3 X's here on the top, 1 X on the bottom. When I cancel, it's going to give me X squared. So I know I got an X squared. So it can't be this one, or this one. And then 5 minus 2 is 3, so it's got to be J. Here, which one is equivalent to 2x cubed to the 4th? I have one exponent. I have one variable, 2 exponents. They don't equal? Nope. So we multiply. And hopefully you've remembered from our earlier problem, this is 2 to the 4th power. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's not any of these. And then 4 times 3 is 12. Another one of those. 2 cubed is, you do enough of these problems, you start to recognize it and memorize it. 2 cubed is 8. I have one variable, 2 exponents. They do not match. Multiplication sign. 3 times 3 is 9, so it's 8x to the 9th. This one, I'm curious to know how many people got this one right. Usually I have 0. So if you actually attempted to work it, even if maybe you got it wrong, but you had a way, pat yourself on the back, because most students don't even attempt this. They just kind of look at it and go, ugh. But once I show it to you, you're going to go, that's easy. When I look at this, I'm going, there's no way for me to solve it unless, rule of exponents, my bases are the same. If this was x to, or 2 to the x plus 2 equals 2 to the 2x minus 2, I could just set the exponents equal to each other. But they're not. So you ask yourself, can I make the bases the same? And I know that 4 is the same thing as what? 2 squared. Let's rewrite this. 2 to the x plus 2 is equal to 2 squared to the 2x minus 2. So now all I have to do, that's the big, oops, I didn't mean to do that. It won't let me undo that, will it? Is 2 to the x plus 2 is equal to 2 squared to the x 2x minus 2. So now all I have to do is set the two exponents equal to each other. So I get x plus 2 is equal to, what's 2 times 2x? That's 4x. 2 times negative 2 is minus 4. And now I'm just going to solve for x. I'm going to move this x over. I get 3x is equal to 6. So x is equal to 2. And again, the big key here is bases and exponents. They have to have the same base. Then the last one here is going to be, you've got x cubed to the a power equals 15, and x to the b power to the 4th equals 8. So you just got to know your law of exponents. I have one variable, x. I have 2 exponents. They don't match, so you're multiplying. So that means 3 times a should equal 15. So a is equal to 5. Here, same thing. 1x, 2 exponents, they don't match. We multiply. B times 4 equals 8. So b is equal to 2. So now they want to know, what is x to the a minus b? What's 5 minus 2? 3. X cubed. And again, the math I've been doing is actually elementary math, multiplication and division tables 1 through 12. But it's just some concepts here that you've got to know and have memorized on how you do the math. So hopefully that was a good refresher. Now, you've got your exit ticket for day 19. And for exit day 19, it's given you an equation. And it's got them equal, but it's asking you, is that correct? Are they really equal? And if you say yes, you should tell me why they're equal. If your answer is no, you have to tell me why. So if all you do is a yes and a no, you'll get it, and you only get half correct. You'll get 5 points off for not giving me the why. Yes and no is 5 points. Why or why not is 5 points. Okay, so exit ticket. Hope you had fun on that, and see you with tomorrow's lesson, or see you in class.